Hello guys, in this video I'm going to show you how to solve search in a rotated array. Given an array of numbers which is sorted in ascending order and also rotated by some arbitrary number. Find the given key. Find if a given key is present in it. Write functions return the index of the key in the rotated array. If the key is not present, return -1. You can assume that the given array does not have any duplicates. Alright. So for example, we're given this sorted array, right? It has 5 numbers. It is sorted in ascending order, but the thing here is that it also rotated by some arbitrary number, right? So as you can see here, the original array should be 1, 3, 8, 10, and 15, but let's say 1, 3, 8, 10, and 15, and here's the end of the array. But because this array is rotated, so as you can see here, it is rotated 2 numbers, right? So let's rotate it here so you can see why it is in this form. So first is 15. It's gonna go back to the head. The next largest number is 10. So come back here, 10. Alright. So now 8 is the last one. And after rotating 2 numbers, it becomes this array. Okay. So it is sorted but also rotated, right? So our task is to find the given key. The key is 15. So as you can see, 15 is at index 1. So the output should be the index. And if we cannot find it, return -1. Okay. So it seems like we find key in a sorted array. So probably they use a binary search, right? But here it's not. It is a modified versions, right? So how wanna get around the rotating issues here, right? So as you can you might remember that in the last video we also have this kind of similar issues when our array is increasing and then decreasing. It's bitonic array. So this one is similar because it it also divided into 2 parts, right? And both parts are sorted by itself in ascending order, but we don't know the boundary, the point where 2 parts cross, right? Here it's 15, and 1 here is when it start to drop, right? 10, 15, and then down to 1. So how to solve it? Let's see. Can we could find probably we could find the maximum number. I mean, we can find the boundary between two regions, right? Means we can either find the minimum or maximum value here. Not value, but the positions, the index. Okay, so if we could find the index here, so it means where it start to drop. So it means we can apply the binary search for the left side and also the binary search for the right side, right? Okay, that's the idea. Okay, let's take a look at more verbal example. Let's say 1, 2, let's say 7, 9, 10, and 1, 2, 4, 5, 7, right, and 8. No, 6, 7. Okay, so we have okay 9 numbers, right? And we need to find, let's say, not number 9. Key is 9. So obviously we must find this number, the largest number. So right next to the largest number will be the smallest number, right? So if we could find this largest one, then we can apply the binary search um, for the left side and binary search for the right side. That will work. But let's think if we could find another way um, to make it better. Like here, we probably need to do 3 steps. To find index of maximum number, right? Then apply search, binary search for the left. I mean, from the maximum index all the way to the left, and apply the binary search for the right. Mean the number right after the max, means from the minimum number all the way to the right. So this will work, but probably one improvement this uh, algorithm is we could do it a bit better here. So let's say, okay, here's a left, right? Here's a right, and okay, where's the middle? We have 9. Oh, so 2 is the middle. Okay, so actually we could we could combine these steps into probably only one loop, right? If we do like this, we probably need three separate operations. But let's see here. If I know the middle one, if I know the middle one values, and I could compare it with, let's say, the lab value, the value of the lab here, and then you can see it is less than the lab here, the number 8 here. So what does it means? It means that the dropping points will be in this range, will be in the middle of lab and middle. Here is a dropping point. It increased to tens and suddenly dropped to 1, right? So that's the reason the value in the middle is less than the value in the lab. So because of this, it also means that the values from the middle all the way to the right will be sorted in ascending order, right? Because our race is rotated, so because it originally sorted in ascending order, so except for this only one point that it is except for this one point, all the other numbers here, we should expect that it is sorted in ascending order. Okay, so because we know that this is sorted, right? So probably uh, we could do the check with the key here to see if in this range or not, right? And if it is not, then it will be, then we could reduce, right? We could eliminate half of the search space here and start to look for in the lab, right? So with this approach, we don't need to find for the max index of the maximum, right? There could be less work to do with this approach. Okay, now for example in this guy, we could eliminate from the middle to the right and start search for this lab to middle -1. Okay, so here we do the same, find the middle, right? And compare the middle to one end, let's say the left hand side. And if the left hand side is less than the middle, it means this part from left to middle is sorted in ascending order, right? So we could then check the key, the value of the key if it is in that range. Else, when it checks on the other half, right? Reduce, when it eliminate half of the search space for each step, just like binary search. Okay, So what we need to do here is that we're gonna start with left and right. Left is from 0, right is from array of length minus 1. So as long as left is less than or equal to right, I'm gonna find the middle index. The middle index will be gonna round it down, left plus right minus left divided by 2. What's that? This will give us the middle index. Okay. Okay. So now we want to know that if we divided the uh, the current search space into two parts, which part is going to be the sorted part and which part is not sorted, right? So if I could check it here, let's say I'm gonna take the left end, let's say the number index left. If it's less than probably equal to, it could be the case that the left, here we don't have any duplicates, but it could be the case that the left index is equal to the middle index. So we could check the equal here. Middle, okay. If this is the case, it means from left to middle is sorted in ascending order, right? Okay, so because it's sorted, we could easily check that if key is in this part, not. So if key is left, will be the number of the left will be the smallest, and number at the middle will be the actually here we should probably check the middle values first, right? So array at middle, if it's equal to key, we could return the middle right away. But if it comes here, here we don't need to check for the case equal, because if the key is equal to middle, we return the middle index here. Okay, if the left is less than the middle, then it means from left to middle is sorted in ascending order. Okay. It could be the case that left is equal to middle. Okay. Okay. From left. Okay. If key is because here is the sorted part. If key is less than is not in this range, means it's less than array. Index left and key is greater than array. Dot index middle. This means not in this part. Else no, it's not n but or not in this part. It means I will need to check for the other part, right? So here is a left to middle. So I will reassign the left here to middle plus one. Why middle plus one but not middle? Because here we check the middle already. It's not equal to middle. But if it is not the case, it means it is inside range. So we could dive into this. And so what it means is I reassign the right middle minus one. Left is the same. Else less than or equal to middle. Okay. If this is not the case, means from middle to right is sorted in ascending order. It means here, if it comes here, it means the number at left is greater than the number at middle. So when it is case, it means the dropping point is on this side. Number the left here greater than number at middle. So it means from middle all the way to the right is ascending order. So because it's ascending order, so we could easily check if the key is inside this or not. So if the key is less than array at middle and the key is greater than array at middle, else now or less than array and greater than array at right. So it means it's outside of range. I could search on the left. So it means I reassign the right. And if it's in this range, I could reassign the left, middle plus one. And if we exit this loop without return here, it means we couldn't find it, so return minus one. Okay, let's untap just 11 and 8. Okay, it works. Double check. Okay, it indeed works. So that is it for this problem. Thanks for watching. See you in the next video.